Hello friends, welcome to our Mathematics Student Support Program for Grade 8. Our topic for today is Pythagoras Theorem. This chapter has been divided into two parts. So let us start with part 1. In today's session, we are going to talk about the Pythagoras Theorem and its applications to right-angled triangles. So here is a picture of Pythagoras. He was in fact a Greek philosopher, and he has provided us with a proof of a theorem which bears his name, and he has also found methods to find what we call the Pythagorean triples, which are sets of three whole numbers which make up the sides of right-angled triangles. Pythagoras' theorem helps us to calculate the length of the diagonal connecting two given straight lines. This application of the theorem is generally used in architecture, carpentry, and other construction works. Let us have a look at some real-life applications of this theorem. So here you can see that we have a right-angled triangle under the staircase. Even on our laptop or our TV screen, we can have a right-angled triangle. In our bookshelf, you can see here we have what we call the right-angled triangle. In houses as well, or here you can see the distance here. We have a right-angled triangle. Now, let us have a quick recall of what was covered previously in grade 7. If you remember, a right-angled triangle is a triangle containing a right angle. That is, it is a triangle having an angle of 90 degrees. Remember, this is going to give us the 90 degrees. This symbol is used to represent 90 degrees. Now, what is a hypotenuse? The hypotenuse is in fact the longest side in a given right-angled triangle. It is found opposite the angle of 90 degrees. So opposite this angle of 90 degrees, we have what we call the longest side, the hypotenuse. Now we move on to the Pythagoras theorem. You need to remember that this theorem applies only in right-angled triangles. We can use it only if we have right-angled triangles. So what does this theorem tell us? It's just that the square of the length of the hypotenuse is equal to the sum of the squares of the length of the two other sides. In other words, the longest side here is C, which is the hypotenuse. So C to the square is equal to the sum of the squares of the length of the two other sides. That is A square plus B square. So the Pythagoras theorem tells us C to the square is equal to A to the square plus B to the square. Remember, the longest side to the square will be equal to the sum of the squares of the length of the two other sides. This is a very important formula for you to remember. Now let us move on to what we call the Pythagorean triples. If you have three integer values which satisfy the Pythagoras theorem, we call these three numbers the Pythagorean triple. Let us consider an example. So we consider the numbers 3, 4, and 5. So if you look carefully, the largest value here is 5. Now 5 to the square gives me 25. Now I'm going to square the other two numbers. So 3 to the square plus 4 to the square will give me 9 plus 16, which is 25. And you can see that 3 to the square plus 4 to the square is in fact equal to 5 to the square. I repeat, 3 to the square plus 4 to the square will give me 5 to the square. That is, the sum of the other two small values will give me the largest value to the square. So we say that 3, 4 and 5 are what we call the Pythagorean triple. Okay, let us consider some examples to apply the Pythagoras theorem. So the first example, I need to find the length of the unknown side A. So you have your right angle triangle. One side is 5 centimeters, the other one is 12 centimeters, and the longest side is 8 centimeters. Remember, the longest side is called the hypotenuse. So we are going to look at the solution. Here we have a to the square. If I recall the formula, the longest side to the square, so a to the square, is equal to the sum of the squares of the two other sides. So a to the square will be equal to 12 to the square plus 5 to the square. This gives me a square equal to 144 plus 25, which is equal to 169. So to find the value of a now, I'm just going to take the square root. So a is equal to 13 centimeters. The square root of 169 is 13. A second example, find the length of the unknown side x. So if you look at this diagram, here the longest side, the hypotenuse, has already been given as 25 centimeters. One of the smaller sides is 7 centimeters, and I need to find x. So here I will have 25 to the square equal to 7 to the square plus x to the square. So my unknown here is one of the smaller sides. So 625 equal to 49 plus x square. And x square will be equal to 625 minus 49, which gives me 576. To find the value of x now, I need to take the square root of 576, which gives me 24 centimeters. Usually, when you have to find the longest side, the hypotenuse, you will have to add. But if you need to find one of the shorter sides, you will have to subtract. Please remember this important hint. We now move on to the third example. I need to find the value of x and y in the given figure. So here, if you look carefully, you can see that we have two triangles. And I need to find the length of x, which is the whole of it, that is BD, and the length of y, which is AC. So for the solution, we will have to consider the triangles separately to find the values of x and y. We first consider triangle ABD. So here is the triangle. Remember, the length of BD was x. AB is given as 21 millimeters and AD is 29 millimeters. So I'm going to apply Pythagoras theorem here, and I need again to find one of the shorter sides. So 29 to the square is equal to 21 to the square plus x to the square. This gives me 841 equal to 441, that is 21 to the square, plus x square. If you recall, I mentioned earlier, to find one of the shorter sides, you need to subtract. So x square equal to 841 minus 441, which is 400. And to find the value of x, I need to take the square root of 400, which is 20. So the value of x is 20 millimeters. Now, remember BC and CD are equal. So to find the length of BC or CD, I'm going to divide 20 by 2. That is the value of x by 2. So BC is equal to 10 millimeters, half of 20. Now I need to find the value of y. we now consider the triangle ABC. So BC was given as 10, AB 21 millimeters, and Y is the length of AC. So Y to the square equal to 21 to the square plus 10 to the square. So if you recall, I mentioned that to find the longest side, the hypotenuse, we are going to add. So Y square will be 441 plus 100, which is 541. To find Y, I take the square root. So here, 541 is not a perfect square number. So you can leave your answer as it is, that is in terms of square root. You don't need to use your calculator, which in fact you're not supposed to do. So you leave your answer as a square root. So here are some exercises for you to practice on Pythagoras' theorem. The first question is quite simple. You need to identify the hypotenuse in the following right-angled triangles. So just label the hypotenuse. Question 2. You need to check whether the following sets of numbers form the Pythagorean triple. So if you remember, you're supposed to take the largest value, you square it, and when you square each of the two remaining values, you add. If this sum is equal to the largest value to the square, this means that we satisfy the Pythagoras theorem, and the three numbers will be called the Pythagorean triple. Otherwise, it's not Pythagorean triple. Number 3, you need to find the value of the unknown side in the given triangles. So you might be asked to find either the longest side or one of the shorter sides. Remember, to find the longest side, we are going to add. If I need to find one of the shorter sides, we are going to subtract. So some additional questions for you. Question 4, find the length of the unknown side or sides. So for part A, you will have to find the length of x. Part B also, part B you will need to find the length of x. And you can leave your answer in square root form if it is not exact. Part C, you will need to find the length of y in part C, and in part D you have two unknowns, x and y. Again, if it is not in a perfect square number, if ever one of the values when you're calculating you do not obtain a perfect square number, you leave your answer in square root form. So we move on to a summary of what we have done in today's lesson. We have learned that the longest side in a right-angled triangle is called the hypotenuse. Here it is C. And the Pythagoras theorem states that the square of the length of the hypotenuse, that is C square, is equal to the sum of the squares of the length of the two other sides. That is C square equal to A square plus B square. You also have some links for additional practice. So friends, we have now reached the end of the first part of this lesson on Pythagoras theorem. We will meet in the next session to deal with the real-life applications of this theorem. So until next time, it's goodbye.